Challenge accepted. Can Microsoft Copilot really save you hours on repetitive data engineering tasks? I ran it through real-world scenarios to find out. From converting CSV files to Delta Parquet tables to debugging in notebooks, I'll show you exactly where it adds value and where it still needs work. Why repetitive tasks are draining your productivity. What if the hours you spend on tedious data cleaning could be cut in half? As a data engineer, you're likely no stranger to repetitive tasks. These tasks are foundational to ensuring clean and reliable data, yet they're the activities that tend to be the most draining. For example, transforming CSV files into Delta Parquet tables may seem straightforward at first glance, but the process often reveals itself to be much more intricate. You need a grasp of Spark along with a willingness to debug every error that pops up along the way. Even something like creating a fiscal calendar table, a standard need in many data workflows, requires a frustrating mix of manual effort and coding precision. The constant context switching between these detail-oriented tasks can chip away at your productivity. It isn't just the sheer monotony of these activities that makes them difficult, it's their ability to consume valuable hours that you wish you could be using for strategic initiatives. Say you've spent the better part of your day debugging a notebook. Every minor syntax error or logic flaw keeps you in a repetitive cycle of testing and fixing. Or maybe you're manually transforming datasets to align with reporting needs, scouring rows of data for inconsistencies. There's a point where you might step back and ask, is there a better way to do this? These moments can add up over weeks or months, forming a pattern that not only slows your progress but also builds frustration. Studies support this struggle. Research shows that automation can reduce task completion times by up to 40%. Imagine taking the time spent on these low-level tasks, from formatting data to performing simple transformations, and reclaiming nearly half of it. This statistic is compelling because it illustrates how much room there is for improvement. Still, for most data engineers, the natural concern is ensuring quality and accuracy. You might wonder whether automation can really handle these tasks as effectively as a manual approach. After all, even a minor error in data transformation can ripple through your entire pipeline, leading to incorrect reporting or downstream issues. Picture this. An overworked data engineer spends the better part of their week caught up in a loop of preparing raw data for analysis. They're handling an array of files, correcting errors, and restructuring datasets so they conform to specific requirements. Sound familiar? This isn't an isolated experience. As Josh pointed out in a discussion about Microsoft Fabric, these manual processes often lead to extensive debugging, which wasn't in the plan when they started their careers as data engineers. The constant pressure to manage these details leaves little time for work that might feel more impactful, like designing creative solutions or optimizing the data workflows themselves. This scenario might sound exaggerated, but it's a reality that leads many data professionals to burnout. Burnout doesn't appear overnight. It builds slowly as repetitive tasks dominate a larger share of your workday. Each instance of manual coding or debugging feels small in isolation, but the cumulative effect can be overwhelming. Whether you're maintaining existing pipelines, cleaning up test data, or troubleshooting a compatibility issue, the time lost adds up. This situation makes it easy to imagine why automation tools have become so attractive in fields like data engineering. Of course, automation isn't just about saving time. It's about improving focus. Without those repetitive tasks consuming your mental energy, you could dedicate more attention to high-level objectives. Things like designing scalable solutions, building machine learning models, or finding ways to extract deeper business insights from your datasets. This shift in focus isn't merely theoretical. We've already seen how tools designed to help with automation have transformed sectors outside of data engineering, so it only makes sense to extend those benefits into managing data workflows. Let's pause for a second and return to the concept of accuracy. Automation promises to save time, but it also has to deliver the same results or better when compared to manual intervention. As much as automation simplifies some processes, tools like Microsoft Copilot still need direction. You can't simply throw your entire workflow at an AI and expect perfect results without guidance. That's why data engineers sometimes hesitate. They want reassurance that the tool will actually align with their needs. The question then becomes, how much effort is required to guide these tools effectively? If the point is to reduce workloads, Will teaching the tool add more complexity? This brings us to Microsoft Copilot. Rather than merely promising a generic automation solution, Copilot is tailored to integrate directly into the workflows you're already using. Whether you're in a notebook interface or working with data transformations, it's designed to take instructions in natural language and execute them as if you had done the coding yourself. It knows how to connect its outputs to tools like Azure Data Factory or Power BI, ensuring that its contributions are ready to plug into the rest of your processes. If automation can save up to 40% of the time required for repetitive tasks, Copilot shows us a practical way to reach that number. Consider a scenario in which a tool like Copilot can handle something like converting CSV files into Delta Parquet tables. While this might sound straightforward to a seasoned data engineer, it's actually a tedious activity that can run into snags. You need to write Spark code, validate the migration, and double-check data formatting. Copilot simplifies this process with one command. It can generate the Spark code for that conversion. You still review the work, of course, especially if your organization has specific rules about formatting or schema definitions. But the time savings are obvious. Instead of slogging through every line of code yourself, you can focus on ensuring the output meets your standards. This notion opens up a new way of thinking about data engineering workflows. Not as static, time-bound activities, but as processes that can evolve. It's an idea that builds anticipation. If tools like Copilot can simplify some of the most detailed and error-prone parts of your job, where else might they be helpful? Could it free you to spend more time on proactive measures like improving data quality at earlier stages in the pipeline? Could it allow you to focus on design instead of debugging? Finally, how effectively does it tackle the balance between automation and accuracy, which always seems to define conversations about implementing AI tools? Microsoft Copilot has made strides in bridging these gaps. It positions itself as a tool that lets you complete tasks without sacrificing precision. By providing a way to automate specific aspects of data cleaning, transformations, and beyond, it suggests you don't have to make hard choices between speed and quality. If you've ever been in the middle of an intricate workflow and wished you could fast forward through parts of it without cutting corners, it's easy to imagine how a tool like this could make that possible. Now, you might be asking how exactly all of this works. Automation in the context of data engineering isn't new. We've had tools in the past that could extract data or simplify code writing. What's changed, however, is that AI-driven tools like Copilot can understand the context of your requests. This capability allows them to handle specific tasks with less upfront effort on your end. Their integration into broader ecosystems like the Microsoft Fabric ensures they can connect to other tools naturally, making them effective from both a time-saving and collaborative standpoint. So how does Copilot manage these tasks intelligently? What practical methods does it use to ensure quality outputs without creating new inefficiencies? These are the questions we'll tackle in the next section. We'll examine the mechanics of how Copilot simplifies data transformations, ensuring it not only understands your input, but produces results aligned with the real-world needs of data engineers. We'll also look at specific examples that show its impact and discuss what to watch out for if you plan to integrate it into your workflows. Keep watching. It gets even more interesting from here. How Copilot automates data transformation in Fabric. Can a single natural language prompt replace hours of manual coding? For data engineers, this idea might sound ambitious, but Microsoft Copilot in Fabric is making it closer to reality. One of the key areas where Copilot shines is in handling data transformations, specifically tasks like converting CSV files to Delta Parquet tables. This can be a tedious process when done manually, requiring a solid understanding of tools like Spark and the ability to write precise code. Copilot changes that dynamic by turning a few well-constructed prompts into functional and efficient code. Let's start with why this task can feel so complex. Imagine you're working with a collection of CSV files that need to be converted into Delta Parquet format for better compatibility, scalability, and performance within your data pipeline. Manually, the process involves using Spark to handle the transformation. You'd need to write code that imports the necessary libraries, loads the CSVs into a data frame, defines schemas, handles potential errors, and outputs the final Delta Parquet files. Not only must you know how to write this code, but you also need to debug it, ensuring that all dependencies are accounted for and that the schema meets your pipeline's requirements. For those new to Spark or less comfortable with programming, this step alone can take hours, especially if errors creep into your workflow. Enter Copilot. Its strength lies in simplifying this workflow into a natural language request. As demonstrated by Inder Rana, a technology specialist at Microsoft, Copilot can transform a detailed task into a manageable process. In his demo, Rana asked Copilot to read the CSV files from the CMS drug prescriptions folder and load them into a data frame. With this single prompt, Copilot generated Python code for Spark, including all necessary import statements, references to the Spark session, and connections to the specified file paths. What could have taken significant time was completed in seconds, showing Copilot's ability to execute instructions in a structured and logical way. The process hinges on what's known as prompt engineering, essentially crafting the instruction in a way that ensures the AI understands the task and delivers accurate results. Rana's demo highlighted how even small changes to your prompt can improve Copilot's output. For instance, specifying that a Spark session is already available or clearly defining relative file paths helps Copilot generate more precise code. This iterative process of refining prompts turns Copilot into a collaborative tool. You're not writing the code yourself, but you're guiding it and ensuring that the AI's interpretation aligns with your goals. By spending a few moments crafting a thoughtful prompt, you save time on the back end by generating a more accurate and functional script. Beyond simply loading data, Copilot also supports more advanced transformations. For example, Rana demonstrated how it could convert columns in a dataset from one data type to another. By asking Copilot to convert these columns to decimal and long types, he was able to generate code that handled the conversion automatically. Similarly, he showed how Copilot could create new columns by combining existing ones, all through natural language instructions. This flexibility makes it clear that Copilot isn't limited to simple transformations. It can handle a wide range of tasks that previously required manual coding. Is this level of automation truly reliable? That's the next natural concern. While tools like Copilot excel at generating code quickly, they're not infallible. As Rana pointed out, the code Copilot generated in his demo was flawless and ran successfully, but human oversight remains crucial. Data engineering isn't just about generating working code, it's about ensuring the code aligns with specific business requirements, follows best practices, and meets the quality standards of your organization. Copilot's outputs are often a great starting point, but reviewing and refining what it produces will continue to be a critical step for any data engineer using the tool. The benefits, however, are hard to ignore. Copilot drastically reduces the time required for these repetitive tasks. Instead of writing the code line by line, you focus on defining the task, checking Copilot's results, and making any necessary adjustments. This shift in workflow allows you to dedicate more time to higher-level objectives, like improving the overall architecture of your pipeline or analyzing the data itself. By automating the foundational work, Copilot helps you move faster and with greater confidence in your processes. Let's consider another possibility. If Copilot can simplify tasks like data loading and transformation, what about more intricate workflows? For example, workflows involving extract, transform, load, ETL processes often combine multiple steps, extracting data from one source, transforming it to fit specific requirements, and then loading it into another system. While we'll dive deeper into this in the next section, it's worth noting that the foundational capabilities of Copilot already point toward its potential for handling these advanced scenarios. Its ability to combine multiple steps into a cohesive process is one of its most promising features. Before moving forward, it's essential to discuss real-world applications and how Copilot measures up against expectations. While the tech demos, like the one from Rana, are compelling, the real test comes in environments where workflows are more complex and data engineers face unexpected challenges. For instance, what happens when there's an error in the input data or the schema is inconsistent? Copilot's ability to interpret and address these nuances is still evolving. In those situations, a skilled data engineer's expertise becomes even more vital. Understanding how to correct inputs, modify results, or adjust processes ensures that the final output meets the desired standards. This brings us full circle to the importance of balancing automation with oversight. Copilot doesn't eliminate the need for skilled data engineers, but it enhances their efficiency by taking over the repetitive and time-consuming aspects of their work. Think of it as a tool that opens up time for you to focus on tasks that truly require human insight and creativity. Whether you're prototyping a new pipeline or identifying patterns in your data, Copilot lets you redirect your energy toward work that drives value for your organization. Another key factor to consider is Copilot's integration into the larger Microsoft Fabric ecosystem. This integration is what allows it to connect so seamlessly with tools like Azure Data Factory, Power BI, and Synapse Analytics. And the result is a smoother workflow where the outputs of one step can flow naturally into the next. This connectivity isn't just convenient. It's critical for ensuring that the efficiencies gained from automation extend across the entire data lifecycles. So, what's the bottom line? Copilot doesn't eliminate all challenges in data engineering, but it transforms how you approach them. A task like converting CSV files into Delta Parquet tables goes from being a multi-step manual process to something you can achieve with a few straightforward prompts. The time savings are undeniable, as is the ability to focus on more impactful work. This potential alone makes Copilot worth exploring, especially for teams looking to improve the speed and accuracy of their workflows. That said, Copilot is not perfect, and there are caveats to keep in mind. Human oversight is still essential, both in crafting effective prompts and in reviewing the results. The tool is powerful, but its impact depends heavily on how well it's used. For organizations thinking about adopting Copilot, investing time in understanding its capabilities and limitations will be key to getting maximum value out of the tool. Before we move on, let's leave with one final thought. Automation tools like Copilot are not about replacing engineers, they're about giving engineers more freedom to innovate. By automating what can be automated, they create room for creativity, problem solving, and forward thinking. In the next section, we'll explore how Copilot extends its capabilities to tackle full ETL workflows, offering another glimpse into how it's changing the game for data engineering. If transforming CSV files is just the beginning, imagine what's possible when Copilot takes on more advanced challenges. Simplifying ETL with plain language prompts. What if you could perform an entire ETL process without writing a single line of code? For data engineers, this isn't just a theoretical idea. It's becoming a reality with tools like Microsoft Copilot. ETL, or extract, transform, load, is a fundamental part of data engineering workflows. It's the process that ensures data from multiple sources is extracted, cleaned, transformed, and loaded into a structure that makes it useful for analytics or reporting. Whether it's a database migration, combining datasets, or preparing data for a machine learning model, almost every data engineering project relies on ETL. Despite its importance, traditional ETL workflows often require extensive coding and debugging. Each step of the process, from querying a database to reshaping the data, involves writing detailed scripts. Extracting data, for example, can mean querying an Azure SQL database where even small syntax errors require extra time to troubleshoot. Transformations are another layer of complexity. This involves converting data types, creating calculated fields, or reformatting timestamps, all tasks that typically demand precise coding and validation. Finally, loading that cleaned data into a destination such as a data warehouse or analytics tool comes with its own challenges. This approach not only demands technical skill but also consumes significant amounts of time, especially for engineers managing large pipelines. Here's where Microsoft Copilot introduces a major change. By using plain language prompts, you can ask Copilot to perform ETL tasks that previously required hundreds of lines of code. For example, extracting data from Azure SQL, applying transformations, and loading it into a Delta Lake can be accomplished without needing to write extensive Python or Spark scripts. Instead, Copilot automates the process, generating functional code based on your instructions. This leap in efficiency removes much of the friction associated with traditional ETL workflows, letting you focus on solving problems instead of focusing on syntax. In one demo by Dan Taylor, Copilot's ETL capabilities were put to the test. He showcased how a simple natural language command like extract data from Azure SQL and create a new column with the order total as quantity times price could result in Copilot producing the necessary code to execute the task. This includes everything from connecting to the database to performing the calculation in a scalable manner. The demo highlighted how Copilot reduced what might otherwise be a 30-minute process to a few seconds, all while maintaining the accuracy one would expect from manually written code. It's a clear example of how Copilot optimizes time without sacrificing precision. One of the standout features in the ETL process is the sheer simplicity of transforming data. In the same demo, transformations such as converting column data types or merging columns were completed using plain text prompts. For instance, by asking Copilot to convert the order date column to a datetime format, the tool not only produced the code needed to make the change, but also annotated why specific lines were included, making it easier for users to follow along. These kinds of annotations are especially valuable for those who might not excel in programming but still need to manage technical workflows. It isn't just automation, it's automation with context. Now let's consider the broader implications of this automation. By simplifying ETL, Copilot creates space for data engineers to focus on strategic decision-making. Think about the time spent cleaning and restructuring data. If those hours could be reinvested into higher priority tasks, like optimizing the logic of your pipeline, improving scalability, or refining analytics outputs for stakeholders, the overall impact on productivity could be massive. This shift in focus allows teams to innovate rather than becoming bogged down by repetitive steps. Another aspect worth noting in Dan Taylor's demo is how Copilot handles one of the most common data engineering requirements: adding calculated fields. For example, imagine you're working on a dataset where the business team requests a new field called profit margin, calculated as the difference between revenue and cost divided by revenue. With Copilot, you simply describe the calculation in plain language, and the tool auto-generates the corresponding code. What's more, the code is built in a way that aligns with best practices, minimizing errors that might arise from manual coding. It's efficiency, but with an emphasis on reliability. That said, the process isn't entirely hands-off. While Copilot excels at generating initial code, refining the output and verifying that it aligns with the specific requirements of your pipeline are still critical steps. Consider cases where your dataset has unique edge cases, null values, inconsistent formatting, or unexpected outliers. Copilot might not identify these issues on its own, meaning a data engineer's attention remains crucial for fine-tuning. Instead of replacing skilled engineers, Copilot enhances their capabilities, acting as a tool that removes obstacles rather than one that takes over entirely. Another compelling use case for Copilot's ETL features involves automating the creation of date dimension tables. Date tables are essential in data warehousing because they allow analytics teams to group data by time-based attributes like month, quarter, or fiscal year. In a demonstration, Copilot created a date dimension table from scratch using information about desired start and end dates. The natural language prompt specified columns such as date, week, and quarter, and Copilot immediately generated code to build the table. For a task that might typically require multiple steps, including writing loops for populating rows or scripting queries for time calculations, completion took less than a minute. This capability is particularly important because time dimensions are often a bottleneck in ETL tasks. Many organizations rely on them for KPI dashboards or trend analysis, meaning they need a robust structure that can accommodate dynamic reporting. Automating this process through Copilot not only saves time, but also ensures consistency in how the table is structured. It's another example of how Copilot removes friction from workflows that often hold up larger projects. The strength of Copilot lies not just in the speed of its execution, but in its integration within the Microsoft Fabric ecosystem. For example, after completing ETL tasks, the data can flow seamlessly into tools like Power BI or Azure Synapse Analytics for reporting and further analysis. Having this level of compatibility across the ecosystem reduces the need for manual intervention, eliminating the risk of errors introduced by exporting or importing data between systems. At the same time, it enhances collaboration since outputs from one task feed directly into the next stage of the workflow. It's also worth mentioning how Copilot's ability to explain its outputs bridges technical and non-technical gaps. When presenting a pipeline to stakeholders, you might be asked to justify certain transformations or calculations. Copilot automatically annotates its code, providing clear justifications for each step. This transparency not only makes it easier to review the process, but also facilitates communication between teams. Non-technical stakeholders can understand why transformations were made, while technical reviewers can confirm alignment with standards. What does all of this mean for the future of ETL processes? Copilot brings an undeniable shift. It lowers the barrier to entry for those who may not be proficient in coding yet still need to manage data workflows. For experienced engineers, it offers a way to escape the grind of repetitive coding and debugging, letting them focus on improving overall pipeline performance. For teams, it represents a way to standardize processes and improve the scalability of their workflows. To sum it up, Copilot simplifies ETL without removing the need for human oversight. It speeds up routine processes like extracting data from Azure SQL, transforming it to match schema requirements, and loading it into analytics tools. By reducing the technical friction involved, it enables data engineers to shift their attention to strategy and problem solving. However, the importance of refining its outputs and adapting them to specific pipeline needs cannot be overlooked. Looking ahead, tools like Copilot show us what's possible when AI integrates into repetitive tasks, and ETL is just one example. Imagine applying these capabilities to even more complex setups, from real-time streaming pipelines to AI-driven optimizations of workflows. But before we dive into those possibilities, there's one specific area where Copilot takes process automation even further, creating fiscal date calendar tables. This traditionally time-consuming code-heavy task is made effortless by natural language prompts, which we'll explore in the next section. The time savings might surprise you, and the precision won't disappoint. Building a fiscal calendar table in minutes. Can a task that once took hours now be done in under 5 minutes? This is one of the most exciting promises that Microsoft Copilot offers when building fiscal calendar tables, a process that is both essential and notoriously time-consuming for data engineers. Every organization relies on fiscal calendars in some shape or form. They organize data across fiscal years, quarters, and months, enabling accurate reporting and analysis that aligns with business needs. These tables are the backbone of financial dashboards, trend analyses, and forecasting, which means they must be precise and tailored to the organization's specific requirements. But creating these tables manually is no simple task. It requires a solid understanding of data transformation techniques and precise coding to ensure all elements, like weeks, fiscal quarters, and holidays, are accounted for. The complexity of fiscal calendar tables becomes even more apparent when you break down the steps involved. You might start by setting the date range, often aligned with fiscal years rather than regular calendar years. Then you need to create columns for attributes like fiscal week, quarter, year, and maybe even calculated fields like week of year or days remaining in fiscal year. For each of these, you'd likely need to write customized scripts. For a seasoned data engineer, this process takes time but is doable. However, for someone with limited coding expertise, creating such a table can feel overwhelming. Every column must be formatted correctly, data types must be specified, and potential edge cases like handling leap years have to be addressed in your script. Even minor errors in the code could lead to reporting inaccuracies down the line. This is why Microsoft Copilot is creating so much buzz around its potential efficiency gains. Greg Beaumont demonstrated this capability in action, showing how Copilot transforms this traditionally complex task into something a data engineer can complete in less than 5 minutes. Using only a natural language prompt, Beaumont asked Copilot to generate a fiscal calendar table for FY 2023 with columns for date, fiscal quarter, and fiscal week. With that single prompt, Copilot automatically generated the necessary code to build the table, including all specified columns, the correct data types, and even a properly calculated date range for the fiscal year. What makes this process remarkable is not just the time it saves, but how much complexity it bypasses. Tasks that used to require debugging, iteration, and deep familiarity with SQL or Python were handled almost instantly. One of the standout aspects of this example is how Copilot automatically handles column specifications. Beaumont's fiscal calendar table included fields that were correctly labeled, organized, and formatted, all without additional input beyond the initial prompt. For instance, the fiscal quarter column was formatted as integers while maintaining consistency with other date fields. The tool also determined the date range automatically based on the fiscal year provided. This kind of automation directly addresses one of the biggest challenges in building fiscal calendars: aligning the table structure with the organization's specific needs. Without the need for manual intervention, Copilot avoids many of the pitfalls that often arise during custom table setup, such as mismatched formatting or misaligned date ranges. This functionality introduces new possibilities for users who need fiscal calendars tailored to their workflows. A key feature of Copilot is its ability to adapt to user-specific inputs. In Beaumont's demo, users could specify not just the fiscal year, but also additional details like custom columns or unique reporting requirements. For example, if an organization needed a column for fiscal half or cumulative fiscal days, Copilot could handle these requests with minimal guidance. This flexibility ensures that the output aligns with varying organizational needs, whether you're working in finance, retail, or supply chain operations. It means data engineers spend less time manually coding and more time addressing higher priority tasks like interpreting the data or optimizing the pipeline where the table will function. Of course, with any automated tool, a question arises: how flexible is the output? While Copilot's ability to generate code automatically is impressive, data pipelines often require adjustments to fit unique use cases. For example, some organizations might adjust the start of their fiscal year to align with specific business cycles, or they might use different naming conventions for columns. This is where Copilot remains a collaborative assistant rather than a fully autonomous tool. The initial code it generates can be easily modified to customize the table further. In Beaumont's example, after Copilot produced an accurate fiscal calendar table, users could still tweak elements like custom column names or additional formatting to ensure the table integrated seamlessly with downstream systems like Power BI or Azure Synapse Analytics. Another important consideration is how this automation helps bridge the skill gap for users without deep coding experience. Building fiscal calendar tables traditionally required expertise in SQL, Python, or Spark. Errors in a manually written script could create ripple effects across an entire pipeline, leading to inconsistent data and wasted time troubleshooting. With Copilot, however, even someone with minimal technical expertise can get started by simply describing what they need in plain language. For example, a junior data analyst who might not know how to create a week of fiscal year column in SQL could achieve the same result by asking Copilot, add a column showing the week number within the year starting from week 1 in July. This opens up the tool to a broader audience while maintaining high-quality outputs. The reliability of Copilot's outputs also points toward its practical value in real-world scenarios. By automating these complex yet relatively standardized tasks, Copilot frees up time for more creative and analytical work. Teams can ensure that their fiscal calendar mirrors business requirements without dedicating multiple hours or even days to building it. At the same time, oversight remains essential. Reviewing the generated code ensures that it meets the specific rules or edge cases that might apply to an individual organization, such as differing fiscal start dates across global teams or the inclusion of holidays in certain regions. Another compelling aspect of this automation is how seamlessly Copilot integrates with the rest of the Microsoft ecosystem. Once the fiscal calendar table is generated, it can immediately flow into tools like Power BI for visualization or into Azure Data Factory for further transformation. This level of integration reduces the handoffs typically required between teams working on different platforms. For data engineers, it's particularly useful to see how Copilot doesn't just automate one step in isolation, but instead provides outputs that fit directly into the broader workflow. If you've spent time exporting or reformatting data across multiple tools, you'll recognize the time savings this represents. What's more, Copilot's ability to explain and annotate its outputs adds a layer of transparency that's invaluable in collaborative settings. In Beaumont's demo, for instance, the explanatory comments in the generated code clarified how each column was calculated, ensuring that anyone reviewing the code understood its purpose. This is a subtle but significant feature. It removes the mystery often associated with pre-built scripts, allowing teams to collaborate more effectively. If a change needs to be made, like adjusting the fiscal week calculation, the annotations make it easier for team members to identify where to make modifications without having to decipher the entire script. It's important to highlight that while Copilot simplifies the process, it's not replacing the role of the data engineer. Instead, it's transforming how data engineers approach their work. In the past, building a fiscal calendar table often required a substantial investment of time. Now, with Copilot automating the repetitive aspects, engineers can focus on finer details like improving reporting accuracy or exploring additional insights the table might offer. It's about shifting time away from routine processes and toward activities that add strategic value to the organization. This brings us to a broader point. Automation tools like Copilot are not just about speed. They're about consistency, accuracy, and scalability. By standardizing tasks like fiscal calendar creation, Copilot ensures that organizations can maintain reliable pipelines while reducing the risk of human error. For smaller teams, this is particularly significant. Instead of relying on a single team member's expertise, Copilot levels the playing field, enabling consistent results regardless of who is driving the task. So, can Copilot really build a fiscal calendar table in under 5 minutes? The answer depends on how you define build. While the initial table creation might take only a few moments, ensuring that the output meets all requirements will likely involve additional tweaks and reviews. Even so, the net time savings are undeniable, and the process as a whole becomes far more efficient. Whether you are dealing with a one-time report or setting up a reusable pipeline, the impact of tools like Copilot is substantial. As data engineers dive deeper into more advanced workflows, the applications for Copilot continue to grow. Fiscal calendars, while complex, are only one example. In the next section, we'll explore how Copilot simplifies another vital part of data engineering, debugging and explaining complex code. This is where Copilot's role as an assistant becomes even more apparent, offering insights and solutions to speed up one of the most time-consuming parts of the development process. You might be surprised at just how much time it saves and how it changes the way you approach debugging altogether. Debugging and understanding complex code. Ever stared at someone else's code and wondered, what does this even do? If you've ever inherited a script from a colleague or revisited your own work months later, you know what it feels like to untangle complex or unfamiliar code. Tasks like this not only slow down workflows, but also create a significant amount of frustration. Debugging and understanding code often involve hours of poring over lines of logic, combing through documentation, or worse, running trial and error changes to pinpoint what's wrong. It's no wonder this process can feel like a bottleneck for data engineers. When faced with a piece of code you didn't write yourself, the first challenge is simply understanding what it's supposed to do. Even a well-structured script can become confusing if it lacks documentation or clear commentary. For example, imagine a data transformation script aimed at loading and cleansing multiple tables from different sources. Without clear annotations, every query, condition, and function needs to be manually deciphered. This effort takes time, especially when comments are vague or non-existent, and that's before you even begin trying to debug the inevitable errors or edge cases that pop up. The frustration builds when errors surface, especially in scripts so densely written that it's hard to separate the problem's root cause from the noise of everything else happening. Debugging complex scripts slows progress, distracts from higher priority work, and requires focused effort to track down issues that may not even be obvious on the first pass. In some workflows, it's common to change one line of code, only to realize several related parts require tweaking too. This trial and error process, while necessary, isn't where data engineers want to spend most of their time. Here's where Microsoft Copilot steps in. Built into Microsoft Fabric notebooks, Copilot offers smart tools to cut through the confusion, enabling data engineers to summarize, explain, and debug code faster than traditional methods. One of its standout features is code summarization, a tool designed to make sense of even the most intricate scripts. For example, if you drop a code block into your Fabric environment and ask Copilot for a summary, it will return a concise explanation of what the code is doing. Josh demonstrated this feature on the Copilot Learning Hub when working with a data engineering workflow. By simply asking Copilot to explain, he received a clear breakdown of how a script was loading and transforming multiple tables. This capability is particularly useful for anyone revisiting older projects or dealing with inherited workflows, where understanding the code's purpose might otherwise take hours. The best part? These explanations are detailed enough to provide a solid understanding of the logic behind the code. Copilot adds context where it's needed most, filling in gaps that would otherwise force an engineer to guess or rely on trial and error debugging. For instance, in Josh's demonstration, the AI-generated explanation didn't just stop at the surface level, it described the intent behind specific steps, such as why a certain column was being transformed or why a join between tables was necessary. This kind of clarity not only strengthens the debugging process, but also provides an opportunity to annotate your scripts for future reference or collaborative use. Debugging features in Copilot go even further. When errors are present in code, Copilot identifies potential issues and offers suggestions for fixes. Let's say you run a notebook containing a Python script in Fabric, and an error halts execution. Copilot doesn't just point out the error message, it reviews the relevant portion of the code, highlights the issue, and recommends specific changes to resolve it. For example, if a typo in a column name is causing a mismatch during a table join, Copilot will not only detect the problem, but also suggest the correct column name if it's available in the dataset. This avoids the need to manually inspect each part of the script, saving valuable time and effort. But that's not all Copilot does. Beyond identifying errors, it actively helps refine your workflow by increasing readability. By asking Copilot to add comments to this code, you can instantly generate annotations explaining what each function, block, or condition achieves. For engineers familiar with the code base, this feature seems redundant. But imagine how valuable it becomes when onboarding a new team member or collaborating across departments. Josh illustrated this when Copilot annotated a piece of his workflow, attaching concise and easy-to-understand explanations to every major step. As he pointed out, these annotations made it easier not only for him to review his own work, but also for others on his team to follow the logic of the workflow. Now, let's address the big question. Can Copilot really fix errors reliably? While its error detection and debugging capabilities are strong, human oversight is still critical. As demonstrated in the Copilot Learning Hub, the AI-generated outputs aren't always perfect. For some errors, the fixes Copilot proposes might require tweaking before they fully resolve the issue. For instance, in one example, Copilot suggested an edit to resolve a data type conflict, but a more experienced engineer might have implemented the fix in a slightly different way to align with specific architectural or business rules. While Copilot reduces the time spent diagnosing and addressing issues, engineers are still needed to ensure the solutions fit into broader technical and organizational contexts. One thing to keep in mind is how Copilot enhances workflows even when it's not entirely perfect. The time saved by having a starting point, whether it's a list of errors, a set of suggested fixes, or an outline of the code's intent, translates directly to improved efficiency. What might have taken an hour to debug from scratch could take just 15 minutes with Copilot assisting. By reducing the cognitive load of diagnosing problems and suggesting solutions, it empowers engineers to shift their focus to optimizing code or improving their broader workflows. The advantages extend beyond saving time. Copilot acts as an interpreter, distilling complex code for audiences with varying levels of technical expertise. If you've ever been in a situation where a team of analysts, engineers, and stakeholders is evaluating a piece of code, you know how difficult it can be to get everyone aligned. With its ability to summarize and annotate, Copilot helps bridge the gap between technical and non-technical contributors. This transparency improves collaboration by ensuring everyone understands what the code is doing and why certain decisions were made. So, where does Copilot fit in the broader picture of debugging and development? It's a tool designed to augment, not replace, human expertise. Its ability to summarize code, identify errors, and suggest fixes reduces the time engineers spend on repetitive troubleshooting tasks, allowing them to focus on larger-scale challenges. As Josh emphasized, while Copilot helps speed up workflows, reviewing its outputs and making adjustments remains an important part of the process. The AI-generated solutions are a foundation on which skilled engineers can build, rather than a one-size-fits-all answer. To bring this full circle, Copilot doesn't just make debugging faster, it changes the way you approach code. Instead of getting bogged down in deciphering unfamiliar scripts or hunting for hard-to-spot errors, you can quickly identify what's wrong, understand the underlying logic, and move forward with confidence, whether you're reviewing code you wrote weeks ago or inheriting a project from a teammate. Copilot acts as a guide that nudges your work in the right direction while letting you retain control over the final refined output. As helpful as these features are, the real turning point comes when you combine Copilot's debugging capabilities with its integration into semantic models. These models allow Copilot to take an even broader view of your pipeline, understanding relationships between tables, datasets, and downstream outputs. In the next section, we'll look at how this capability not only enhances debugging but also transforms how data engineers deliver smarter, more intuitive analyses for their teams. With semantic models powering Copilot's insights, debugging becomes just one part of a much larger picture, connecting technical problem-solving with effective data storytelling. Leveraging semantic models for smarter analysis. What if your data pipeline could explain itself to your entire team? For many organizations, the gap between producing technical insights and making them understandable to everyone, from engineers to business managers, is one of the biggest obstacles in leveraging data for effective decision-making. Semantic models, a key feature of tools like Power BI, are designed to address this challenge by acting as a bridge between raw data and simplified, meaningful representations. These models enable users to explore data using intuitive relationships, metrics, and hierarchies rather than digging through complex columns and tables. But even with semantic models, interpreting insights often requires guidance, a process that can slow down workflows. Microsoft Copilot builds on this foundation by integrating with semantic models to derive insights and make interactions with data more natural and efficient. The role of semantic models in data analysis can't be understated. These models serve as a structured, business-friendly layer on top of raw datasets, enabling users to interact with data in terms they understand. For example, a semantic model might refer to net revenue as a predefined calculation of income minus returns and discounts, meaning users don't have to construct this calculation manually every time. This approach simplifies the analysis process and makes tools like Power BI accessible to people who aren't specialists in data engineering. But while semantic models are powerful, they often require significant effort to set up, maintain, and relate back to technical workflows or reporting tools. That's where Copilot steps in to change the dynamic. By integrating seamlessly with semantic models, Copilot simplifies how insights are generated and communicated. It uses the semantic structure to guide its understanding of the data, ensuring that natural language prompts can be translated into meaningful analysis. Let's take a more hands-on example. Suppose you're using Power BI to explore sales metrics and want to analyze late deliveries by region for the previous quarter. Instead of writing intricate queries or using drop-down filters, you can ask Copilot in plain language to show a comparison of late deliveries across regions for Q3. Because the semantic model already understands key elements like late deliveries and regions, Copilot accesses the model and pulls the necessary data into a table or chart. The real advantage here is how Copilot leverages the semantic link feature to create native interactivity with data. Interactivity means that Copilot doesn't just run static commands. It fully integrates into live analytics environments like Power BI reports. You can update filters, refine parameters, or adjust granularity directly in your report, all while Copilot responds in real time to your inputs. This functionality allows you to move between asking questions and interacting visually with data, creating a loop where insights are refined continuously. As the semantic link ensures Copilot works natively within the semantic model, this integration guarantees consistency in how data is accessed and displayed. This cycle of query and response leads to another interesting benefit, improving communication between technical and non-technical team members. Let's face it, data analysis often comes with a language barrier. Engineers working in notebooks describe tables, joins, schemas, and transformations, while business users ask how sales figures changed over time or why inventory discrepancies occurred. With Copilot serving as the intermediary, that gap narrows. By pulling data from semantic models and presenting it in a clear, interactive way, Copilot democratizes access to accurate insights. It's no longer necessary for every stakeholder to understand SQL, Spark, or even advanced Power BI techniques to get actionable information. The example of late deliveries by region illustrates this perfectly. Once the initial visualization is generated, team members can interact with it directly, without needing to enlist an engineer every time a new filter or adjustment is required. This transparency enhances collaboration during discussions and presentations. Stakeholders can adjust parameters live, such as filtering by specific suppliers, without disrupting the flow of analysis. Additionally, annotations and explanations provided by Copilot clarify how the data was derived, instilling confidence in the results. This process isn't limited to generating one-off insights. It extends into more robust workflows. By integrating with semantic models, Copilot enables data scientists and engineers to work more cohesively. Since semantic models are shared across the Microsoft ecosystem, outputs generated in one tool are accessible in others. For example, a semantic model created in Power BI can be used to define metrics that Copilot references inside a Fabric notebook. This level of interoperability means that teams can reuse definitions like net profit margin or customer retention rate across different systems, ensuring consistency. Whether driving strategy discussions or operational decisions, everyone works from the same structured dataset, leading to more aligned outcomes. The ability for Copilot to operate within semantic models extends beyond generating visuals or summaries. By linking these models back to the lakehouse environment, Copilot enables a continuous feedback loop within the data lifecycle. For instance, data scientists analyzing customer purchase trends generate new insights or identify corrections to existing algorithms. These improvements can then be pushed back into the lakehouse environment, updating the semantic model over time. This iterative approach ensures that each step of analysis feeds back into creating more accurate and meaningful datasets for future projects. One of the greatest strengths of this functionality is how it supports better decision-making at every level. Because semantic models allow Copilot to focus on the relationships and hierarchies already present in the data, it automates the heavy lifting of technical tasks. Generating a monthly sales report no longer requires fielding multiple queries or exporting raw data for manual review. Copilot pulls and organizes insights directly, based on the way the model was designed. Business teams see relevant figures without chasing explanations. Engineers retain control over data structures, and the overall process becomes significantly faster. The semantic link feature plays a critical role in enabling this smooth interactivity. With it, the data Copilot stays connected not just to your reports, but also to the models behind them. This native integration eliminates breakdowns in workflows where data exported from one tool becomes outdated or disconnected from the source. It also enhances collaboration between engineers and analysts by ensuring they're using a single source of truth. When everyone contributes to and works within the same semantic structure, inconsistencies are reduced and collective efforts are aligned more effectively. But perhaps the most transformative aspect of Copilot's use of semantic models is its ability to empower individuals outside of technical teams. Non-technical professionals like managers or marketers can ask questions and receive clear outputs without requiring specialized skills. This supports broad-based data literacy within organizations. As more people interact with data independently, they make faster, informed decisions, easing the bottleneck that often comes when analysis requests pile up for already busy engineering teams. The deeper implication is that the very concept of data analysis is moving from technical isolation to team-wide collaboration. As businesses increasingly rely on data-driven insights, tools like Copilot are redefining how teams interact with and share those insights. Instead of relying on back-and-forth handovers between analysts and engineers, users at all levels of expertise gain hands-on access to actionable insights. Semantic models are no longer static datasets, they're tools for interactive exploration driven by AI-powered assistants like Copilot. It's worth emphasizing that Copilot isn't just capable of reading and using semantic models, it also helps in creating them. For organizations still building out their analytics infrastructure, Copilot can automate the process of developing semantic models, defining metrics or hierarchies, and publishing them for use across various tools. This means even companies with limited experience using structured models can adopt them more easily. By reducing the setup complexity, Copilot lowers the barrier to implementing best practices in data organization. This kind of automation doesn't eliminate the need for human input, it amplifies it. Semantic model creation through Copilot still depends on understanding business requirements, defining critical metrics, and designing a structure that reflects organizational priorities. However, Copilot speeds up the implementation by taking over repetitive tasks like defining field relationships, creating calculated measures, or specifying table hierarchies. As a result, engineers spend less time building these models from scratch and more time refining them for accuracy and usefulness. The benefits ultimately come back to accessibility. With Copilot automating technical processes and enhancing semantic model capabilities, data starts to feel less like a specialized domain and more like an integral part of every decision-making process. This isn't just about saving time, it's about creating opportunities to use data in more meaningful ways. Teams focus on strategic questions and trust the tools to handle operational efficiency in the background. While the possibilities are exciting, it's essential to ensure tools like Copilot are deployed responsibly, especially in collaborative settings where accuracy and security are critical. Data governance plays a crucial role in making sure semantic models and AI-driven tools provide reliable results without exposing sensitive information or introducing errors. In the next part, we'll look at how Microsoft ensures Copilot remains secure through robust governance tools like Purview, addressing the balance between usability and protection in modern workflows. Security isn't just an abstract concern, it's key to ensuring that workflows with tools like Copilot remain efficient and trustworthy. Stay tuned to see how data engineers can innovate without putting their data at risk. Ensuring security and governance with Copilot. How do you ensure AI tools don't compromise your data security? As AI becomes deeply embedded in workflows, this question is critical. Tools like Microsoft Copilot show immense promise in improving productivity, but they also introduce new risks. Oversharing data, misconfigured permissions, and unauthorized access can expose sensitive information, putting organizations at risk of breaches or compliance violations. To avoid these pitfalls, robust data governance becomes essential in any AI-driven workflow. Organizations must balance leveraging AI's capabilities while ensuring their valuable data remains secure. Data security concerns often arise from the way AI tools like Copilot interact with sensitive information. For example, if permissions for datasets aren't properly configured, Copilot could inadvertently access restricted data. Something as simple as an overshared SharePoint link or a broken inheritance setting could accidentally make private files accessible not just to Copilot, but potentially to other unauthorized users as well. For organizations managing large amounts of sensitive data, these risks highlight the need for strong governance measures that provide visibility and control over how data moves through AI workflows. Without proper safeguards, even minor oversights in permissions could lead to significant damage. To address these risks, Microsoft offers a comprehensive suite of tools designed to ensure that data governance remains intact in AI workflows. Two of the most notable solutions include Microsoft Purview and SharePoint Advanced Management. These tools help manage permissions, apply sensitivity labels, and create policies to restrict Copilot's access to particular types of data. Let's take a closer look at how these features align with addressing real-world issues around data security. Microsoft Purview plays a central role in securing data for AI workflows. It allows organizations to establish clear data loss prevention (DLP) policies. These policies control how data is classified, labeled, and accessed within the system, ensuring that sensitive information such as customer PII or financial records is protected. With Purview, it's possible to apply granular safeguards through custom-built data classifications. For instance, a company may choose to label data as confidential and then configure policies that prevent Copilot from interacting with files carrying that label. This ensures that AI-driven tools only access low-risk data, closing potential gaps in governance and protecting critical assets. Data classification within Purview is particularly flexible. Organizations can create trainable classifiers that identify sensitive data based on examples, even when such patterns aren't easily defined. For example, if your organization handles proprietary content that doesn't follow a specific format, you can train classifiers by providing sample documents. This approach ensures Purview can identify similar data and protect it accordingly. Purview also supports exact data match. EDM classifiers, which are especially effective for structured data like customer IDs or financial transactions. These tools make it possible to manage classification and labeling in an automated, scalable way, an approach far more efficient than manual reviews. SharePoint Advanced Management complements Purview by tackling issues specific to collaboration and file sharing. A common risk occurs when access permissions are overly broad, such as when files are shared with everyone except external users. This kind of blanket sharing may seem harmless, but it creates opportunities for unauthorized access. SharePoint Advanced Management provides detailed reports highlighting sharing links, site privacy settings, and any permissions that deviate from organizational policies. These reports allow site owners to identify issues like broken inheritance or unrestricted sharing. By addressing problems directly, businesses can prevent sensitive files from being unintentionally exposed. Another powerful feature of SharePoint Advanced Management is restricting site access during cleanup operations. For example, if an administrator identifies a site where permissions have become too broad, they can temporarily prevent users from accessing the site altogether while permissions are reviewed and updated. Using PowerShell commandlets, it's even possible to block content from being used specifically by Copilot without changing the overall permissions for users. The command set SPO site with the restrict content or wide search to true parameter ensures Copilot cannot access data from particular sites, even if users have legitimate access to that content. This feature is particularly effective for highly sensitive or confidential projects. The combination of SharePoint Advanced Management and DLP policies in Purview creates a layered approach to governance. For instance, if a financial spreadsheet is mistakenly labeled as general instead of confidential, the DLP settings can still prevent that document from being used by Copilot if it resides on a restricted SharePoint site. These multi-layered controls ensure no single point of failure creates undue exposure, providing peace of mind for data owners and security teams alike. To demonstrate how these tools improve security in practice, Microsoft provides real-world examples of their functionality. For instance, data assessments in Purview allow organizations to scan SharePoint libraries for sensitive content, such as unprotected files containing credit card information or personal customer data. These assessments deliver valuable insights, showing not only which files carry sensitive data, but also whether appropriate sensitivity labels are missing. Businesses can address these gaps proactively, applying safeguards wherever necessary. Purview can also track AI interactions, letting data governance teams monitor how tools like Copilot access sensitive data. Features such as the Activity Explorer provide visibility into risky AI interactions, ensuring that any questionable patterns are flagged early and addressed promptly. At this point, some may wonder if these safeguards are enough to fully trust Copilot, especially in environments handling critical data. While tools like Purview and SharePoint Advanced Management significantly reduce risks, they aren't fully autonomous solutions. Their effectiveness depends on how organizations configure and maintain them. A strong governance framework, including regular data audits, clearly defined policies, and employee training is essential. Even the most advanced tools need careful supervision to ensure they remain effective over time. For example, as new datasets are added or existing ones evolve, DLP policies may require updates to reflect the changing risk landscape. Similarly, regular site access reviews should be scheduled to ensure permissions remain appropriate and aligned with organizational priorities. It's also worth considering how these tools streamline compliance. Whether your organization must comply with GDPR, HIPAA, or industry-specific regulations. Maintaining clear restrictions on how sensitive data is accessed and used can simplify audits and reduce liability. By labeling data consistently and enforcing policies through tools like Purview, companies can demonstrate that they meet regulatory requirements without needing ad hoc manual interventions during compliance reviews. Furthermore, DLP policies make it possible to generate audit trails for AI interactions, ensuring that Copilot's use of sensitive data is traceable and properly documented. One of the most significant impacts of implementing these safeguards is how they enhance overall confidence in using AI-driven tools. With the right controls in place, organizations can unlock the productivity benefits of tools like Copilot without compromising security. For instance, engineers can use Copilot to automate repetitive coding tasks while being confident that private data remains inaccessible. Analysts can interact freely with Copilot when building reports, knowing that sensitive content has been properly labeled and protected. In both cases, the balance between usability and security is what ensures AI adoption contributes to productivity rather than creating new risks. Of course, this doesn't mean every organization will implement these controls flawlessly from day one. As data governance matures, administrators will likely encounter situations requiring iteration, whether it's refining DLP policies, improving classification schemes, or revisiting site privacy settings. What's important is treating governance as a continuous process rather than a one-time setup. With tools like Purview providing insights at every step, organizations can monitor progress and course correct when necessary. Over time, having these systems in place builds trust across teams, making it easier to adopt AI technologies on a larger scale. Microsoft also provides detailed blueprints to guide organizations in configuring these features effectively. These blueprints outline practical steps for improving governance within Copilot workflows. For instance, they recommend prioritizing low-risk sites for Copilot access first, implementing long-term solutions to reduce oversharing at the file level, and using PowerShell scripts to enforce granular restrictions where needed. Following these guidelines creates a structured, phased approach to improving security and governance. In summary, safeguarding data security isn't optional when using AI-driven tools like Copilot. Risks like oversharing and unauthorized access can be managed effectively with tools like Microsoft Purview and SharePoint Advanced Management, coupled with strong DLP policies. These solutions provide the visibility, control, and flexibility necessary to enhance productivity while protecting sensitive information. With proper setup and ongoing governance, organizations can fully realize the benefits of Copilot without compromising the security of their data assets. In the next section, we'll shift our focus back to the productivity gains Copilot brings to the data engineering workflow and the metrics that illustrate its full impact after sustained use. The real impact, productivity metrics, after 1 month. What happens to your workflow after a month of using Copilot? It's a fair question, especially if you've been skeptical about relying on AI for something as critical as data engineering tasks. Many engineers start with cautious optimism, intrigued by the idea of automating tedious work, but hesitant to fully trust an AI-generated solution. To answer this, let's explore the measurable impacts Copilot can have on productivity over a month, drawing insights from what we know about its capabilities in automating repetitive tasks, reducing errors, and improving efficiency. Before diving into numbers, it's important to set the stage for the type of metrics you'd want to track after integrating Copilot into your workflow. For most data engineers, time spent on repetitive tasks such as transforming data, creating fiscal calendars, or fixing errors is a key benchmark. Cutting down these hours not only saves time for other projects, but also reduces the cognitive load that comes with mundane activities. In addition to time savings, you might also track error rates. How often did manual coding lead to bugs in your scripts before adopting Copilot? Finally, consider the ease of collaboration. Did tools like Copilot's commenting and summarization features help make teamwork faster and smoother? These types of metrics give clear indicators of whether Copilot is delivering on its promise. A common source of skepticism lies in whether AI tools can handle tasks with the same level of accuracy and attention to detail as manually written code. Engineers by nature are accustomed to precision. Many are initially hesitant about whether Copilot's outputs will not only work, but also align with the specific requirements of their pipeline or their organization's standards. The early days of adoption can feel like a test, reviewing every output to ensure it meets expectations. But, as repeated demonstrations of Copilot have shown, this skepticism often starts to diminish as the tool proves its abilities. Take, for example, Greg Beaumont's demonstration of building a fiscal calendar table using Copilot. This is a task that would traditionally demand a significant amount of coding expertise, from setting up date ranges to handling fiscal weeks and quarters. With Copilot, Beaumont completed the table in just a few minutes, relying on a natural language prompt. This shift from crafting and debugging code to simply reviewing automated output represents a measurable efficiency gain in workflows involving routine data engineering tasks. While the demo doesn't quantify the time saved, the fact that such tasks now take minutes instead of hours suggests the potential for massive productivity gains. Another clear example of Copilot's time-saving capabilities appears in Indorana's exploration of converting CSV files into Delta Parquet formats using Spark. Rana demonstrated how a simple natural language prompt could generate Spark code that would otherwise take a significant manual effort to create. For data engineers working with large data sets, these kinds of transformations are a critical part of their daily work. After a month of integrating Copilot into their workflow, many engineers would likely notice a significant reduction in the amount of time spent writing and debugging this kind of code. Instead of focusing on syntax and formatting, they can shift their attention to higher-level problem-solving or optimizing their pipelines. Similarly, Dan Taylor demonstrated Copilot's ability to handle ETL tasks, such as extracting data, applying transformations, and creating new calculated fields, all with plain language prompts. Users no longer needed to rely solely on coding experience to perform everyday data tasks like adding calculated metrics such as profit margins or converting columns to specific data types. This kind of flexibility leads not only to time savings, but also to a smoother workflow where tasks that once felt repetitive become nearly effortless. It's easy to imagine how, after a month of regular use, these small time savings for individual tasks add up to something far greater. But what about error reduction? Reducing the time spent debugging is another key area where Copilot makes a noticeable impact. Before automation, engineers might spend hours sifting through logs or tracing errors back to their root cause. Mistyped column names, mismatched schemas, or incorrect joins are all common culprits that grind workflows to a halt. Copilot's ability to identify the source of an error and suggest fixes doesn't just speed up the process, it makes debugging far less stressful. Over weeks of working with Copilot, engineers often find that they're catching mistakes faster, meaning fewer roadblocks and less friction in their workflows. One of the most consistent themes during Copilot's demonstrations and use cases is how it simplifies reviewing and understanding code. For example, when Josh showcased Copilot's ability to summarize code and add annotations, it became clear how this feature could amplify collaboration among teams. Imagine sitting down with a teammate to review a complex query. You might spend an hour dissecting it manually. When Copilot automatically generates a summary of the code's purpose and provides comments for each section, that same meeting could take just 15 minutes. Now, multiply that kind of efficiency gain across multiple team interactions throughout a month. The cumulative effect becomes undeniable. While much of the evidence around Copilot's impact so far is qualitative, coming from specific user demonstrations and examples, it's not hard to extrapolate what real-world metrics might look like. If a task like creating a fiscal calendar shifts from a 2-hour coding exercise to a 5-minute Copilot prompt, you can start to quantify the time saved across an average work week. Similarly, replacing hours of debugging with automated suggestions means engineers have more bandwidth to focus on projects that drive business value. Over 30 days, those time savings and efficiency improvements can transform how a team prioritizes its workload. Of course, one important question remains: will these productivity improvements sustain themselves over time, or do they level off after the initial excitement of adopting the tool fades? The answer likely depends on how users adapt their workflows to fully integrate Copilot. Research and demonstrations suggest that the tool's benefits grow over time as users become more proficient in prompt engineering and reviewing Copilot's outputs. For example, the ability to refine natural language prompts to produce increasingly accurate code means that users can achieve more with less effort as they gain experience. Moreover, Copilot's integration into the broader Microsoft Fabric ecosystem reinforces its long-term potential. By connecting with tools like Power BI, Azure Data Factory, and Purview, Copilot doesn't just help with isolated tasks, it streamlines entire workflows. After a month of practice, data engineers can begin to leverage these integrations more strategically, baking automation directly into their data pipelines. User feedback also supports this idea of compounding benefits. While specific user testimonials or quantified case studies aren't available, the examples of Copilot in action show a clear trajectory. Tasks that once felt daunting are suddenly approachable, and processes that required hours of manual input now take minutes. As users get comfortable with the tool, these changes in efficiency and ease of use are likely to increase, creating a virtuous cycle where Copilot becomes an increasingly natural part of daily work. It's also important to acknowledge the caveats. Copilot isn't perfect, and users still need to actively review its outputs to ensure accuracy. While it dramatically reduces time spent on coding, transformations, and debugging, engineers must remain vigilant about verifying that the outputs align with their exact specifications. For instance, if Copilot proposes a transformation that doesn't fully account for edge cases in your data, you'll need to step in for adjustments. But even with these additional steps, the net time savings remain compelling. By the end of the first month working with Copilot, most engineers and teams are likely to see significant shifts in how they approach their work. Repetitive tasks feel less of a burden, errors are resolved faster, and collaboration feels smoother. While Copilot won't replace the expertise required for high-level data engineering, it undeniably augments those abilities, enabling engineers to focus more on innovation. Moving forward, it's clear that tools like Copilot are redefining what productive workflows look like in data engineering. By automating tedious tasks, streamlining complex processes, and facilitating better collaboration, they allow teams to approach their work with newfound efficiency. But this brings us to an even bigger question. Is Copilot truly a must-have for every data engineer? In the final section, we'll reflect on what makes Copilot a game changer for the profession and why taking the time to explore it could fundamentally shift the trajectory of your data career. Let's wrap it all together. Why Copilot is a must-try for data engineers? Is Copilot the future of data engineering? Based on the capabilities explored throughout this video, it certainly feels like we're on the verge of a major shift. Microsoft Copilot has introduced tools that streamline workflows, automate repetitive tasks, and enable collaboration in ways we haven't seen before. But like with any AI tool, there's skepticism. Are these benefits as reliable as they seem? Are the use cases as practical in real work environments as they are in demonstrations? These are valid concerns to address before drawing conclusions about its long-term impact. Let's first reflect on the key features that set Copilot apart, especially in the context of data engineering. Its standout ability is generating code based on simple natural language prompts. Whether you're transforming data, querying a database, or even creating a fiscal calendar, tasks that would require hours of writing and testing complex scripts are now condensed into a single prompt and seconds of processing time. This capacity alone could transform how engineers spend their time. And we've explored use cases that demonstrate just how efficient this can be. For example, Greg Beaumont showed how Copilot could generate an entire fiscal date calendar in moments, applying correct column specifications, data types, and date ranges without requiring the user to write any lines of code. This type of automation removes much of the friction associated with repetitive manual work. Beyond task automation, Copilot makes debugging and understanding complex code significantly easier. In Josh D's example, Copilot summarized code, explained its purpose, and annotated specific lines with accessible language. These features are helpful not just for seasoned engineers, but also for newer team members trying to understand larger data structures or code bases quickly. As Josh noted, it's ideally set up for the expert, but for the beginner, it's a great learning tool. It bridges technical experience levels, accelerating comprehension and reducing the time it takes for individuals to contribute meaningfully to projects. One of the more impressive aspects of Copilot is how it simplifies ETL processes. Traditionally, ETL workflows require extensive coding for extracting data, applying transformations, and loading that data back into usable formats. Dan Taylor demonstrated how Copilot could handle these steps with a single, plain language prompt, such as extracting data from Azure SQL and applying calculations to create new columns. By translating human instructions into correctly formatted code, Copilot removes barriers for data engineers who may spend hours debugging syntax errors or adjusting schemas manually. After a few tries, many users realize they can execute these tasks with faster turnaround times and fewer errors using Copilot's automation. These concrete examples show the range of tasks Copilot can simplify, but they also raise questions about reliability. AI tools aren't perfect, and Copilot is no exception. Error detection and debugging features are strong, but human oversight remains essential. This is something Indarana emphasized. He explained AI technologies are still new, so having a human review is important. Human in the loop, that's the term being used these days. The idea here is not to eliminate the need for data engineers, but to enhance their work. Copilot provides a foundation, whether it's explaining a snippet of code, summarizing errors, or suggesting solutions, and leaves the decision-making and refinement to the engineer. This collaborative approach ensures that automation doesn't come at the cost of accuracy. Another area where Copilot really shines is its use of semantic models for smarter analysis. Semantic models are essential for connecting raw data sets to macro-scale insights that are easy for non-technical teams to understand. Copilot's ability to integrate with these models isn't just a technical convenience, it's a bridge that makes data pipelines more interactive and accessible for everyone involved. For example, if a marketing team wants insights into product performance, they might traditionally need to involve a data engineer to build a query or extract the necessary metrics. With Copilot using semantic models, even these non-technical stakeholders can ask plain language questions, and the AI will generate data visualizations or summaries directly, all based on pre-configured hierarchies and relationships in the models. The entire process becomes smoother and collaboration improves across teams. By now, it's clear that Copilot offers significant productivity benefits, but where does this leave skepticism? As explored earlier, some concerns center on trusting AI outputs and ensuring that these tools fit seamlessly into existing workflows. There's also the real question of learning curves. Even though Copilot simplifies how we interact with data, many users will need time to master crafting prompts effectively or understanding where Copilot's strengths and limitations lie. That said, step by step, engineers who invest in learning the tool start to see how it complements their workflows instead of disrupting them. Another compelling argument for trying Copilot is the time savings it unlocks. If we revisit the examples in this video, repetitive tasks like coding fiscal calendars, conducting ETL workflows, or debugging errors are reduced to a fraction of their original effort. Even if Copilot's outputs require review or modification, the net time saved is substantial, especially over longer project timelines. As Indarana described, Copilot capabilities have the potential for transformational change in how we work. These words are a powerful reflection of how Copilot isn't just a tool, it represents a shift in how data engineers approach their day-to-day responsibilities. A particularly striking part of this is how both beginners and seasoned experts stand to gain. Beginners can use Copilot as a learning tool, as Josh highlighted when he described how it helps them get boosted right into, oh, this is what all these random words mean. It's like having a tutor that guides you through complex code while still producing working outputs. For experts, it's not about learning technical fundamentals. It's about automating the foundational work so they can focus on solving more challenging problems. Imagine freeing up hours of your work week to look beyond repetitive debugging tasks or data transformations and spend that time designing better architectures or finding new ways to optimize pipelines. Those aren't just marginal benefits. They represent transformative shifts in how you allocate your professional energy. It's also essential to understand that Copilot's potential isn't limited to isolated tasks or environments. By integrating deeply into the Microsoft Fabric ecosystem, it ensures compatibility across the entire data lifecycle. Whether you're working in Azure Data Factory for ETL, Power BI for dashboards, or Purview for governance, Copilot connects seamlessly across these tools. This level of integration makes it more than just a code generator or debugging assistant. It becomes a core part of the modern data engineering environment, enhancing every phase of data workflows from start to finish. Now, let's address a key point. What do you lose by not exploring Copilot? The answer is simple: time and efficiency. The ability to use natural language to perform tasks that once required specialized coding skills lowers the barrier to productivity. Organizations that adopt Copilot gain a competitive edge in accelerating project delivery and reducing costs tied to inefficiencies. On an individual level, failing to explore this tool means missing an opportunity to shift focus from manual tasks to work that truly adds value. Whether you're an individual contributor or part of a larger team, the risk of losing efficiency in an industry that thrives on speed and precision is too high to ignore. But adopting Copilot isn't a plug-and-play solution. Thoughtful use is vital to unlocking its full potential. It's important to invest time in understanding what kinds of tasks benefit most from automation versus those that require careful manual intervention. For instance, while Copilot excels at pattern recognition and straightforward transformations, tasks requiring deep contextual awareness may still require a team's expertise. Balancing this nuance is what ensures Copilot serves as an enabler, not an overreach. So, Is Copilot a must-try for data engineers? Based on everything discussed, the answer appears to be yes. It provides tools that speed up repetitive processes, simplify complex workflows, and bridge communication gaps across teams. Whether you're just starting out or have years of experience, the efficiencies it introduces are hard to ignore. From creating a fiscal calendar table in minutes to debugging code automatically, it's clear that Copilot doesn't just save time, it transforms how you approach data engineering as a whole. The key takeaway here is that Copilot is not just another productivity tool, it's a resource designed to amplify what engineers can achieve. Whether you're easing into automation or ready to fully embrace its potential, Copilot has something to offer. At this stage, it's clear that not exploring it means missing out on significant productivity gains that could redefine the way you and your team operate. So, here's the call to action. Don't just take my word for it. Test Copilot for yourself. Whether you're working on notebooks in Fabric, building semantic models, or managing ETL processes in Azure, integrate Copilot into your workflow and see the impact firsthand. And if you're still unsure, start small. Use it to automate a task you've done 100 times and compare your results. Chances are you'll find yourself wondering how you managed without it. Stay tuned for more content exploring AI-driven tools like Copilot and how they're reshaping data engineering. Copilot isn't just a time saver, it's a paradigm shift in how data engineers work. By combining automation, code generation, and contextual insights, it transforms workflows into more efficient and streamlined processes. Indarana believes these capabilities are going to be very valuable, highlighting how Copilot changes not just speed, but how engineers approach challenges. I encourage you to experiment with Copilot in Microsoft Fabric and see firsthand how it reshapes your tasks. Share your experiences in the comments so others can learn from your insights. In future videos, we'll explore more AI-powered tools designed to further simplify the data professional's workflow. Stay tuned.